is have Nathan. Why don't you move over there?
What? No, we're doing this one. Wait, you want us to do this one or this one?
The ones on the front. The ones that are just definite integrals. Yeah, so why don't you sit over here? All right. So let's have some strategy conversation about number one. What thoughts are out there?
So you have to change square root of x to the power of 1/2.
Okay. Have to or can?
Can.
Because I do I have one? Like in my case, it's simpler.
Okay. So there is no, if you're looking at the foldable, Anthony, I'm going to give you the foldable for right now. There are no integration formulas that involve square root of x in the answer, except for one. There is one.
So 1 over 2.
Right, that's the one if you have like the square root of x in the denominator that you might be thinking about this. So definitely if you want to rewrite, sure. As long as it's legal. So I could say the integral from 0 to 4, x to the half plus 1, the whole thing squared dx. Now, two questions I always want you to be asking yourself is number one, is it legal? Number two, does it make the problem better? Does this make the problem better? I'll show you how to use that in a little bit.
I think it might have been easier if we would have done it like that because it's all of the equation is squared, right? And so
Right.
if we did the box.
Right, you're going to have to square out this whole expression over here. So if you're going to do the box, go ahead and do the box, that's fine. Right, x to the half plus 1, x to the half, plus 1, x to the half times x to the half. Is that just x? X to the 1/2. X to the 1/2 plus 1, make sure I'm not going wrong there. I want to do the definite integral from 0 to 4 of x plus x to the 1/2 and another x to the 1/2. I want to be careful here.
2x to the 1.
Is going to be 2x to the 1/2 plus 1, and that's what I'm integrating with respect to x. Now at this point, you've got x to the 1, so that's a power of x. 2x to the half, that's a power of x, plus a constant. Are you guys all pretty convinced that you can find the antiderivative? So Nathan, what's the antiderivative of x going to be?
1/2 x 2.
Right, 1/2 x squared, because really this is x to the first power. Anthony, how about antiderivative of 2x to the 1/2? How are you going to do that?
I actually did it another way.
Okay. So let's go back to that
Oh,
question.
but okay, antiderivative of that
Yeah,
one.
what's the antiderivative of 2x to the 1/2?
Wouldn't that just be... Okay, I'm trying to... So it would be three halves on top.
Okay, good. This is exactly the way I would do this. Think about the exponent first. I have to add 1 to the power. So 1/2 plus 1 is 3/2. Then what do you do?
And then you go
So
n, and then you go 1 over n plus 1.
So it's going to be 1 over 3/2 in front, but really, like, let's not even bother writing that. 1 over 3/2 is really 2/3.
Yeah,
And I'm going to multiply by 2.
4/3.
So I'm going to get 4/3. Plus the antiderivative of 1
X.
is going to be x. Now I've got to evaluate from 0 to 4. So just a lot of plugging in. So 1/2, 4 squared, 4/3 times 4 to the 3/2 power, plus 4. Good news coming.
minus 0.
All that is 0. Now, don't fall for it. It's not just 0 because 0 is your lower limit of integration, but if you actually plugged in 0, 1/2 of 0 squared is 0. 4/3 is 0 to 3/2, 0 plus 0. It's all 0. But if there had been like an e to the x in here, e to the 0 is not 0. If there had been a cosine of x in here, cosine of 0 is not 0. You want to be careful. And now we just need a little bit of cleaning up. So 4 squared is at 16. Half of that is 8. 4 to the 3/2. Nathan, you weren't here yesterday when we were talking about this, but when you have a fractional exponent, the thing that you want to focus on first is the denominator. So when you say 4 to the 3/2, that really means square root of 4. Square root of 4 is square root of 4? 2. And then you're gonna raise it to the third power, so 2 cubed, 8. 4/3 times 8, we've got 32 over 3, plus this last guy over here is 4, so you could say it's 12, plus 32 over 3, or if you get a common denominator, 68/3. Guys in the back, how'd you do it the first one? 68 over 3?
Yes.
Okay. Friends up front, we're okay?
Is it okay if we don't like put it together?
Okay, but, right, my answer is always gonna be the same. It's gonna depend what section of the test you're on. Free response, stop here. Heck, let's be real. If it's free response, where are you gonna stop?
All the way.
As soon as you plug in, get out. Don't go any more. But multiple choice, I am going to expect you to go all the way down to 68/3. And with the AB kids, often it's getting to this final simplified answer with the fraction is where things start to fall apart. So I want you to get the practice now while we have the time. Why don't you guys take a little bit of time, have some strategy conversation about, let's jump down to number 3. I want to go check in with the friends in the back.
I screwed it.
Okay.
It's easier to square.
No, you have to square.
Exactly, that's what we're talking about.
So, I mean, it's like watching somebody type it.
Oh,
Carmen, yeah.
Um,
Carmen print.
do we square it or you just all like this?
Are you asking the question of like, about the order?
Yeah.
Okay, so think about your options here. What's 4 cubed?
16 times 4. 24. 64.
64, now take the square root.
8.
8, do the other way. Take the square root, take the square root forward.
2.
2, now keep it.
8.
Which way was it here?
0. 4.
Well, hold on. I didn't like mark it. Second one should be easier, where you take like the root first, because the root generally, not always, but generally makes things smaller.
Alright.
That's right, so you make the answer smaller before you raise it to a power.
Alright.
Good. Alright, so friends up front, what's the strategy here at number 3?
To distribute each of our grades.
Okay. Is that legal?
No.
I mean, I know I'm boring, I keep asking y'all the same question. Or I guess it's the same 2 questions. Number 1, is that a legal move?
Yes.
Is it legal to distribute?
Yes, it is.
It's illegal. So e to the 3x, if I take that and I distribute through e to the 3x times e to the 3x, e to the 6x minus e to the 3x times e to the negative 3x. E to the 3x times e to the negative 3x, those bases are the same.
Wouldn't that just be 1?
Right, bases are the same, you add the exponents together, so now you've got e to the 0 and e to the 0,
1.
1. Alright, Victoria, the antiderivative, it's all yours. What are you gonna do?
That it would be 1/6
1 over 6,
times e to the power of 6
e to the power of 6x, yeah,
minus x.
minus x, and now I evaluate from 0 to 2. Alright, Anthony, the plug-in part, it's all yours.
1/6 times e to the 12
1/6 e to the 12th
minus 2.
minus 2. I'm just gonna keep using those parentheses, so
Yeah,
I'm being really, really careful.
Then minus 1/6. Yeah, minus 1/6.
Minus, okay, I'm gonna write it out just
Okay.
for the sake of, let's write it out. Right, maybe there's some simplifying I can do here, I'm not even really interested, okay? I'm so glad that I'm so glad though that you knew that this guy over here was 1/6. Right, a big mistake, and it's not just an AB kid mistake to make, I would make the same mistake. Oh, that lower limit's 0 again like before. And a lot of times they see 0 at the bottom and they jump too soon. You've got to think about what would happen if you actually did the plug-in. You'd get 1/6 e to the 0, but e to the 0 is 1. Good. So we're going to have 1/6 e to the 12th minus 2 minus the 6th. If I combine the fractions, that's negative 2 over 1, so negative 12 over 6, negative 1 over 6. negative 13 over 6 is the perfect final answer that I'd expect you guys to go for on the multiple choice. Free response, stop here. Don't waste your time. All right, good luck with number 4. Guys in the back, if you are on number 5, there's supposed to be an F in front of the parentheses there.
Which one are we doing?
Okay, so t over the square root of t
4.
gives t to the half plus t to the negative 6. Yeah, you're good.
Which one are we doing? Yeah.
So in order to make this work, you need to make a W. You need to. So. W. Do you see the W? Okay. So antiderivative of sine of kx, you fold the W together and you open it up. So the antiderivative of sine of kx is negative 1 over k times cosine of kx. Hmm? So that one. The antiderivative is, it was on the yellow. It's on the yellow, negative 1 over k cosine of k. So that's how it would work. And then if you wanted any of the ones in the back, the W, what's the antiderivative of 1 over 2 square roots of x? Okay, push it together, fold it apart, and square it. But it has to be in W formation for this to work. Okay, this is mine. Do you want this one? Okay. Okay.
So after, it's funny, it's after, after make the W.
Yeah, in order to make this foldable work, you need the W. All right, what's the strategy down here at number 4? What have we tried?
What I first did is, because you know how sine squared plus cos squared equals 1?
There you go.
I thought of just changing the top to sine squared of beta.
Okay, so you know that sine squared theta plus cosine squared theta is equal to 1. So if I were to subtract the cosine theta, that means that sine squared theta is 1 minus cosine squared. So you get to the integral from 0 to pi over 4 sine squared theta over cosine squared theta d theta. Is that true?
Yes.
Is it legal to do the simplification?
Yes.
Okay. Does it make the problem better?
If you keep it like that, yes. But if you go on to the next step, no.
Okay. Maybe it looks a little bit better in this way. And so what do you think the next step is?
Well, what I did, and it didn't really work out. Is
Did you rewrite this as tangent squared theta?
Yeah.
Okay. I'll tell you, that is true. Sine squared theta divided by cosine squared theta is tangent squared theta. But antiderivative of tangent squared theta is not one that any of us in the room know, myself included. It's not a known thing. So although everything that you did is legal, not helpful. Need a new idea. Need a new idea. Why do the 3 of you in the back look like you're on a break? That's like the least amount of urgency I've ever seen out of the 3 of you. What else could we do? We had Anthony's idea of a trig identity in the beginning. That was legal, but got us to something that didn't help. What else could you do, Rogelio? What else do you see?
You could separate them and put 1 divided by cosine squared theta minus cosine squared
Okay.
divided by.
So my question for you, it's always going to be that same series of questions. Is that legal?
Yes.
Right? It is legal to rewrite one fraction as 2 different fractions. Now, the next question is really the important one. Does this make life better?
Yes.
Why?
We know what 1 over cos squared of beta is. and
Okay,
that's
what is 1 over cosine squared of theta?
secant squared?
That's
beta.
actually secant squared theta minus cosine squared of a cosine squared
1.
is going to be 1. That now is hopefully a little bit better, because I bet if I asked you what's the antiderivative of secant squared theta, you
Tan
know
of x.
exactly what that is. It's going to be
Tan of x.
not tan of x,
Plus chart.
not tan of x.
When you
Oh,
have
tan of beta.
tangents,
and not 1/2 tangent squared, it's just tangent theta, because the derivative of the tangent is the secant squared. Minus antiderivative of 1. It's not x. I'm going to have to be that picky. Minus theta. Theta is your variable you've got to match. So now you're going to go from 0 to pi over 4. So tangent pi over 4 minus pi over 4 minus tangent of 0 minus 0. Tangent of pi over 4 is 1. Minus pi over 4, tangent of 0 is 0, so we get to 1 minus pi over 4.
You for... Oh, yeah. I don't know what I was thinking of. 'Cause I was thinking about Charlie, but then once you subtract them, it gets eliminated.
Right, remember when we're working with definite integrals, we don't worry about the constant of integration because they would cancel out. Okay, curious. 1 minus pi over 4. Is that a positive answer? Is that a negative answer? Is that 0?
Positive answer.
It's positive. Victoria, what do you think? 1 minus pi over 4, is it positive? Is it negative? Are you not sure?
1 minus pi over 4.
Yeah.
Yep, positive, negative, or not. Okay, now I heard pi is like 3.14. Pi divided by 4, I don't actually care what that is. All I care about is how does that compare to 1.
Yeah. It's smaller.
3.14 divided by 4 is
Smaller.
smaller than 1.
Yeah.
1 minus smaller than 1 has to be
Positive.
positive. Okay? Good. All right, so guys in the back, why don't you come back up front, please? And we've got about 16 minutes, which is about what I was hoping for. For the next couple of days, we are going to be playing around in the world of the application problems. Your homework tonight, if you look on the back page, is just oh, exactly. That must be what it is. It's more practice with definite intervals. I want you to, I'm going to keep pushing you guys to develop your skills. You've got to get the definite integrals and indefinite integrals by hand under control. I think we're in a great place, but it could always be better, and that's why we're going to get the practice. Okay. Tonight's homework has nothing to do with any application problems whatsoever. It is all skills-based. But I want to spend the next 15 minutes at least tackling these 4 problems that are all application problems. I'll tell you right now, these are all questions you guys have done before. We're going to try the individual black and white cups one more time. Chepe's not here. It seems like a safe time to try it. Chepe, if you have black and white cups at home, feel free.
What's the purpose of that?
Okay, wait, what was?
Okay, we never, the downside with the black and the white, what black is death and white is surrender. I don't know what the upside there is. I think black is thinking.
No, this is about this one right here. We
Right.
gave up on the one.
Right, they're both negative. So, you know, let's white. White is thinking. White is thinking because it's the light bulb going off in your head. Everybody has to start on, you can't start at dead. You have to start at thinking. Start at thinking, don't start at brain death. There we go, not even the right cups. I didn't miss you at all, not even a little bit yesterday. All right. Everybody's got 1 minute on their own to read through this problem, read through this first application problem, and decide what you're going to do. After a minute, we'll check in, we'll see where we are. Water is added to the tank at a rate of RT equals 2 plus 5 square roots of T liters per hour, where T is the number of hours since 7 a.m. tank originally contained 1,000 liters of water. How much water is in the tank at 4 p.m.?
So this is zero.
We're in a state of emergency.
We are not in a state of emergency. As long as you're with me, you're fine. Okay, we'll keep going. Okay, see 3 people moving in the right direction. All right, Brian, what were your thoughts on this one?
Find the integral of RFT
You're gonna find the integral of r of t dt. I bet you probably did a little bit more than that, right?
and add 1,000.
And add 1,000. I bet you did a little bit more than that.
Oh, from 0 to 9.
From 0 to 9. Why from 0 to 9?
That's 0 is the time that the rate started, and then 9 is the
Okay,
when we
so
want.
since 7 a.m. means time t equals 0, and at 4 p.m. I saw a little bit of this happening, a little bit of like thinking about the clock. 4 p.m. is going to be t is equal to 9.
9.
Why are we integrating? Now I care greatly about the answer to this question. Why are we doing an integral? There must be a reason. What's the reason?
You're trying to find how much, like, total.
I want to find how much, and what did I give you? I gave you R of t. R of t is a rate function, right? That has units of liters per hour. When you see a rate, you integrate.
Oh.
Hey! You've got a rate function, you're going to find the definite integral. The one adding the 1,000, I'm going to do that because I want to know how much is in there at 4 p.m. When I put this whole thing together, you guys know this, it has a special name.
Fundamental? No.
That 1,000 plus the definite integral from 0 to 9, what is that really? It's the fundamental theorem of calculus. This is your initial value plus your total change. And that's going to equal your final value. So this is your fundamental theorem of calculus. We're going to stop there and try another one.
Oh, the 2.
Okay, right now I'm not as interested. I want to just focus on the word problem and the setup, because then after this it's nothing more than the work that you were doing earlier. Okay, 1 minute to think. Can I get some brave soul in the second one? A car travels with velocity given by v of t equals t squared minus 1 over t kilometers per hour. Time t equals 1 minute. The car's position is x of 1 is equal to 3. Determine the displacement of the car from 1 to e. What did you do, Rogelio?
And integrated from I 1 1 to E
from 1 to E.
of 4V of T respectively.
Okay, and specifically, that's gonna be t squared minus 1 over t? Okay. dt, how many of you guys have the scissors set up?
I just have BFT.
Oh, so you have v of t, but you're gonna have to integrate it, so you're gonna have to plug that in. What about the fact that the initial position is 3?
Plus 3.
Does the initial position even matter?
That's the really good question. Does the initial position matter?
No, because it's only asking for the displacement.
I want displacement.
Oh.
Right, displacement is the integral from a to b of v of t dt. We don't care about the initial position, I just care about the integral of the velocity. And Lucia, if you found the antiderivative of t squared minus 1 over t, what's that going to be?
It'll be 1/3 t cubed
1/3 t cubed
minus natural log of absolute value of
minus the natural log of the absolute value of t. And I've got to evaluate from 1 to e. So, 1/3 of e cubed minus the natural log of e minus 1/3 of 1 cubed minus the natural log of 1. If I wanted to simplify natural log of e, you guys could all tell me. Natural log of e, 1. Natural log of 1
0.
is going to be 0. So I could maybe simplify this to 1/3 e cubed minus 1 minus 1/3, or 1/3 of e cubed minus 4/3. And Anthony, what would you tell me for the units here?
Kilometer?
What do you think, Nathan? Is he right? Okay. If your velocity is being measured in kilometers per minute, dt is going to be measured in minutes. When you multiply those together, it has to be kilometers. Do the units make sense? Sure. We're talking about displacement. Everybody okay? All right. See what you can do with the next one. I'm going to put 3 minutes on the clock. I'm looking for the perfect final answer. If you totally get stuck, move your cup from white to black. The signal of death. You have, I'm not even sure what you're doing with the red cup there. Rule breaker.
It is? Or is it? Okay. You still didn't, you didn't write down the, I know.
Okay, so try cosine.
Like, don't use this one?
If you already know the answer, cosine is how it gets in practice. So the sign up.
Yeah, okay.
You did the work.
Okay, so clearly I did not do a good job thinking about this one. Several of you being super smarties. So exciting. So exciting. Your initial setup hopefully looks like -2 to 2 sine pi x over 4 dx. Just getting there gets you the first point. Now, at least 3 of the 6 of you figured out that the area had to be 0. Why?
Because
Victoria, why?
because you're using the equation sign and the limits of.
The limits of integration, what about them?
Integration are 2 and -2 because you're using sine and they are their opposites. The answer would be 0.
Okay, and the issue is that the sine function is a, what's the fancy word for this?
Even.
Odd function.
For what?
Sine function is an odd
Yeah.
function. It has that rotational symmetry. So the area that you get from -2 to 0 is exactly equal to, but opposite from, the area that you get from 0 to 2. Now, part of why I wanted to do it this way is I really wanted to see how well you guys did with the integration here. Right? This is going to be sine of k times x, where what's the k? K is going to have to be pi over 4. Right, I chose to write it as pi x over 4, but you could rewrite this if you wanted to as pi over 4 times x. So the antiderivative of sine has to be cosine pi over 4 times x, but it's going to be negative, times 1 over k. So 1 over pi over 4 is 4 over pi. And then you're going to integrate from -2 to 2, and because you're else you're done, smart, we know the answer is 0. Good. Good. I'm interested in what you guys can do with this last one. Feel free to work with a partner if you need to.
Really?
Have faith. Have faith in the Smarticle particles.
Yes.
How many of you guys have this as your setup? Right. Average value is 1 over b minus a, the integral from a to b, f of x dx. Antiderivative of secant of x times tangent of x? Secant of x. So you've got to evaluate secant of x from 0 to pi over 4 and then divide by pi over 4. So this is really secant pi over 4 minus secant of 0 divided by pi over 4. And if I was really pressed to tell you what the secant of pi over 4 is, I would have to do this. There's nothing else that I know how to do. I'm going to change secant to 1 over cosine and do a little bit of work there. And so I know cosine of pi over 4 is going to be square root of 2 over 2 minus cosine of 0, I think, is 1 divided by pi over 4. And this should be square root of 2 minus 1 over pi over 4, or even better, 4 times square root of 2 minus 1 over pi. I'm not as worried about you're getting to the final, most simplified answer. I'm interested in setup, I'm interested in finding the antiderivative, and can you get here, and could you stop there? Let's assume it was free response. Okay. We're all set with the homework tonight?